This is problem 31.45. It says a time-varying current I is sent through a 50 millihenry inductor from a source as shown in this figure, where this is your source and then this is your inductor. The current is constant as I is equal to negative 1 milliamp, so it's constant here, until time is equal to 0. From time is equal to 0, it starts to vary according to this plot here. You're asked to make a graph of the EMF across the inductor as a function of time. So first we need to have a relationship between I and E, which is this one right here, where E is equal to negative L di over dt. L is just 50 millihenry. Because we're given this data in pretty large chunks of time, we're going to use the delta notation, so delta I over delta t. So let's see how I changes for every chunk of time. Going from 0 to 1 millisecond, so here to here in pink, I changes from negative 1 milliamps to 1 milliamps. So that's a change of 2 milliamps total. Delta I over delta t is just going to be 2 milliamps divided by 1 millisecond. That's going to give us 2 amps per second. Now all we have to do is take this number, plug it in here, multiply it by negative 50 millihenries, and we get an EMF of negative 100 millivolts. Okay, so then let's do it again between 1 millisecond and 2 milliseconds. Delta I is equal to 0. So delta I means there is no change in the current, it's flat. So that means EMF is going to be 0. From 2 milliseconds to 3 milliseconds, this green region, delta I goes from here to here. So that's 1 milliamp. Delta I over delta t is going to be 1 amp per second. So the EMF is negative 50 millivolts. From 3 milliseconds to 4 milliseconds, right here, this is kind of drawn a little bit wrong, but essentially it's supposed to cross down in the middle here. So it's like crossing at this point here, which is essentially just saying that we have a drop of negative 1.5 milliamps. So then delta I over delta t is negative 1.5 amps per second. So then the EMF is going to be plus 75 millivolts. Same thing when we go from 5 milliseconds, which is here, 4 milliseconds, which is here, to 5 milliseconds, we have a drop down like this, which is negative 1.5 milliamps. Delta I over delta t, negative 1.5 amps per second, EMF of plus 75. Here it's flat again, so the EMF is 0. All you have to do now is take these values and plot them for their corresponding times, right? So here, 0 to 1. Okay, well, from 0 to 1, we had 100 millivolts. So you just take that number and you draw a line here and you keep doing it. So here, negative 100 drops down to 0, goes back to negative 50, rises all the way up to 75, stays at 75 for 2 milliseconds, drops back down to 0, and then stays at 0. And that is essentially all the problem.